Hi everyone, this is my voiceover of the series that I originally recorded for my overseas audience, and now, since there is some interest from my Silicon Valley community, I decided to quickly translate it. Today we'll take a look at our database tool that any small business can use to organize its work efficiently. Any small business needs to create and store information about employees, products, vendors, transactions, accounting, payroll, expenses, and so on. To do that, we'll look at a simple database tool where we can combine all these functions. So we have a GUI, graphical user interface, where we've created a login window, a power button, and placed a logo. With the power button, we close the program and exit it. The logo image can be changed. We'll look at that later. And in the login window, we created two login states, two sets of credentials, operator and admin. Later, we'll look at creating multiple credentials with different permissions, but for now, we'll have just two. The operator has permissions to work with databases, read-write, and the admin has additional permissions to delete records and tables. Text-based systems would need a whole permission microservice just for this. In LabVIEW, it's literally two states and a couple of wires. Let's look at the difference. We'll first log in and work in our program as operator, then we'll log in as admin and see the difference. The password 123 is set here. Later we'll see how it can be changed. So the program opens in operator mode, and here we see the taskbar and the table. On the taskbar, we have the following buttons: Find all databases, databases in use, database tables, database table refresh, auto size, DB table columns, DB database search, sort num, sort by column, save txt, view size, insert record, replace cell, DB table name to create table, cancel, DB table column to create, cell size and add column, rows and columns, and power. But right now, only two buttons are active, as you can see: Find all databases and Power. When we click Find all databases, we get access to the next window, DB in use. Please note that we have active and inactive buttons. For user convenience, we enable and disable some buttons, making them disabled and grayed out if they are not needed or not used in subsequent operations. We select the database, for example, the first one. We have a total of 5 here. And now we get access to the next menu, choosing a table from this database. And here you can see the names of all the tables that exist here. Let's look. We have a table inventory, a table structure FAB, 5 test station tables that we created in previous episodes, and the table vendors. Yes, all these tables, inventory, structure, FAB, and vendors, are new, added here. They contain fictional names, tasks, departments, jobs, emails, and phone numbers. You can see we're using celebrity names here to make working with this data a bit more fun. It's always nicer to debug a query when the dataset says Bill Gates and Adam Sandler instead of user 1527 and row 998243. But we can choose any table now and work with it. For example, let's start with the test station table number 1. Let's say we have the timestamp column. We want to find all records for March 19. To do that, in DB table columns, we select the column timestamp ID and enter the date March 19 in DB search. Press DB search button, and the search gives us all records in this table for March 19. Then we can press DB table refresh and see the entire table again. Now, for example, we want in index ID in the first column to find all records with the numbers 15 and 16. For that, in the database search window, we type 15, 16, and DB search gives us all records with index 15, index ID 15 and 16. Now, let's check how the sort function button works. So we do DB table refresh, and for example, we want to sort in ascending order. To do that, we select the column current in milliamps, the second column. We choose it in DB table columns and press sort by column. And it gives us the values in this column in ascending order. In the second column, current in milliamps, all numbers are now in ascending order. And next we want to sort, for example, by index ID. We select the column name in the DB table columns window again and press sort by column, and our index ID values are all sorted in ascending order. That was numeric sort. Now we'll check how alphabetical sorting works. We select the structure fab table. Here we can use auto size so we can see all records. The auto size of columns is already done, and we can clearly see all data in the columns of this table. And here to test it, we select the column employee name, column number 2, uncheck sort num and press sort by column. And the names in the employee name column are sorted in alphabetical order. A, B, E, J. Here everything is sorted alphabetically. And next, let's select another table, for example, the one where we have the largest number of records, maybe this one. And here, by the way, on the right where rows and columns are, we see the number of rows and the number of columns in this table. So in this table, we have 89 rows and 6 columns, which is very convenient. In this program, actually, we're using a limit of 1000 rows displayed on the screen. Why do we do that? In real databases, the number of rows records can reach millions or billions. Obviously, if we don't limit the number of rows, then when we open a table with that many rows, our computers simply won't be able to hold that much data in RAM, operational memory, and our computer will just freeze. But when we do a search, we do not have that limitation. As an example of how large databases can be, I can tell you about Walmart's database. This is the largest retail company in the US. They write all operational data in their databases, even including cash register receipts. And searching for some piece of information in their databases can take up to several months, even when using very powerful computers. So in our LabVIEW tool, we stay pragmatic. We show up to 1000 records on screen and not 10 million rows plus a spinning cursor and coffee break for the operator. But all these search optimizations we'll look at later when we study the source code of this program. Next, we have the button save.txt file. Let's see how it works. It shows us the path where the file was saved. I click on it and the window pops up. Save table to txt delimited file. I choose OK or cancel. Let's say OK and it shows me the path. Database table saved in file in a specific folder with a specific path. And let's check it. Let's follow this path and see where the file is. So now I open C, Program Files, DB Tool, Report Table, and here's the file that we just saved with the number 201, 304. This is what the file looks like. The table was written here. Okay, we press OK. Next, we have the button View Size. What do we need it for? When we use the next two buttons, Insert Record and Replace Cell, we need to take into account the cell size. The cell size in each column is defined when the table is created and is not changeable, so it's very important not to exceed the cell size here. I press View Size button and we can see the size, the names and sizes of our columns in this table. And let's remember that the number of characters we put into the cells must not exceed the size shown here, this numeric value. Next, we have the button Replace Cell. Replace Cell means we can replace data in any cell. Let's say I select the Structure Fab table and want to change a name. For example, to another last name. I change the last name and press Replace Cell and it asks me, replace Bill Gates with new record Bill Johnson. I can say OK or cancel. I choose OK and it's immediately replaced. The data is updated in the table and this green color tells us that the change has been made. For example, we want to change a phone number. Let's take another row and change the last 4 digits of the number. I press Replace Cell and it again asks replace this number with new number. I say OK. And that's how our changes are applied. Next, using the inventory table as an example, we'll look at the Insert Record button. First, let's check the cell sizes so we don't exceed them. Here I press View Size and see that the cell size should be 50 characters in all these cells. That's clear. We close it. And by the way, yes, obviously we can programmatically limit the number of characters entered to the cell size, but in this case, we're just looking at the basic database principle. We're creating a new group of inventory items. Let's say we want to add something else we might need in stock, for example, pens. So I type pens and then enter the data for this new item. Later, we'll look at automation of receiving and writing off the inventory, but right now we're just looking at the principle of how to create a record using our function. So let's say pens arrived at our warehouse and the inventory manager needs to enter them into the database. We enter item ID, for example, like this. Let's say quantity 1000, price maybe $1.25 per unit. Tax, yes. Maximum stock, for example, I set it to 1500. Minimum stock, let's say 100. Reserve should be 50 and we'll send back, for example, 2, hypothetically. And the vendor ID will be, for example, 2 as well. Initializer, the person who placed the order, will be Adam Sandler, for example. Hazard, no. Department ID, for example, I'll write Hollywood again, not too creative today. And so I've entered all the data. And now if I also try to type something into an inactive field, meaning a column that doesn't exist yet, if I type some data there, then the insert record button immediately becomes inactive if I type in an active field. But when I'm in an active field, insert record works. In a text-only system, you'd probably get a cryptic error. Here the UI just quietly says, no, this column isn't real yet, and protects your data. So I press insert record and notice that all the data are immediately inserted into the active fields, highlighted in green, and the data I typed into the inactive field are automatically removed. This way we prevent the operator from making a possible mistake. Next, we have the table creation function, create table. We already have a table called vendors, and let's say I forgot about that and want to create such a table again. I type the name vendors into DB table name to create and press the create button. A pop-up window appears saying this database table already exists, meaning such a table already exists in this database. I press OK, so again we've protected the operator from making a possible mistake. Let's create a table named log. We type the table name into DB table name to create and click anywhere in the table. A window with column names and cell sizes appears. Here we want 6 columns, and later we'll use this table to log all changes made by the operator. So the first column will be called record ID, the second column will be function ID, the third column will be operation ID, the fourth will be error ID, the fifth is operator ID. That works. And then timestamp ID will keep as is. We check that allow null is checked everywhere, and we pay attention to the cell sizes. We need to be careful with the sizes because we are considering long-term logging into this table over many years, and we need to plan the cell size in this column in advance. The smaller the cell, the less space our database will take on disk. Here, regardless of the actual number of characters, we declare how many characters each column will reserve when creating the table. So in the first column for record ID, let's say 10 characters are enough. Function ID 50, operation ID 50, error ID will set to the maximum to 55, operator ID 20, okay, and timestamp ID 50. That's it. We're done here. So we've finished defining the table structure very quickly, and all that's left is to write it to the database. I press create DB table log. The table is created and appears in the list of all tables in this database. Here it is, log. We immediately do auto size to fit the columns width and headers. This table will later be populated automatically. will create and go through that algorithm later, but for now I'll just fill one row or a few rows with random values, some numbers here, for example, like this. Now I press insert record and all data is inserted. We do auto size again to expand it to fit, and now we have a working table that will be filled automatically. We'll add a new column to this table, and here it's also important to consider the size. Here we type the column size. It's shown here, cell size 100. That works for me. And we'll name the column, for example, K ID. We press add column, okay. The column is added. Let's see. Now we can't do the insert record yet. We can only replace an empty place with some record. I type something into the cell and press replace cell. It shows replace empty cell with new values such and such. I say OK and it writes it. Again, the same thing. If I want to change it, I change the value and press replace, and it shows the old record and the new record asking to confirm the replacement. OK. So these are the operator functions we've looked at today. As we improve our program, we'll be adding more features, but for now we have the minimum necessary set of functions for an operator to work with databases. Now let's see what additional functions the administrator has. I log in as admin, enter the password, and as we can see, we now have additional functions here, the red buttons. This includes changing and saving the password for the operator. Here the first button is save password. We now also have to specify the database path, database location, default if empty, and saving this path. Here we should note that if the database path is not specified, meaning the path field is empty, then the default databases will be used. The ones installed when the program was installed in this folder where our program was installed. And we also have added buttons highlighted in the red: delete record, delete table, and delete column. At the moment they are disabled and gray, meaning inactive. So let's see how save password works. I press the button and the window opens where I can change the operator password or the administrator password. If I change something here, then I press confirm, or if I change my mind, I press cancel. Very easy and simple, but obviously only the administrator can do this. This is where LabVIEW feels like a real control center. Operators get safe, limited access, and admins see extra red buttons that say handle with care, instead of digging through pages of backend config files. Later, we'll use a more complex system for creating operator privileges. Instead of the generic operator, we'll have the name of a specific user. We'll be able to give this user specific privileges to limit their use of certain functions or, on the contrary, allow them. Now the database location, the window for the database path. We press the three dots and I already have the default database path selected here, the DB tool program folder, the database DB folder. And if it weren't already selected, I would manually choose that path. Then select the folder and press Save Path. I press OK, and now let's see where this path is stored. We go to our program folder, Windows, Program Files, DB Tool, Folder Config, and here's the file config.ini. This is what the path to our databases looks like. The operator and administrator passwords are encrypted and protected here. That is, when we press that Save Path button, it created this config.ini file. The passwords and the path are protected here, and we talked about how to encrypt them in previous episodes on encryption-decryption. If you haven't seen our previous episodes yet, you can find them on our Laplanda Tech channel. And here you can also replace the logo with your own. Here's the program logo file. Your logo file must have the same name and the file size is indicated in the name. From a security point of view, this is nice. Instead of hard-coding connection strings all over a text project, we store one encrypted config and let LabVIEW do the clean wiring for us. Next, we proceed just like the operator. We choose Find All Databases and the Database in Use window opens. I select the first database and choose the table we just created, log, the log table. We'll practice the delete function on it now. First, we have delete record. We place the cursor somewhere in a row, more precisely into a cell in that row. Press delete record and the entire row is deleted. But we can also change our mind. There was a cancel button. If we want to delete a column, we select the column here in DB table column, for example KID, and press delete column. I get the question delete column KID. I can say yes or no, OK or cancel. I press OK and the entire column is deleted along with all records in it. Next, delete table. Let's say I accidentally selected the wrong table to delete. I selected structure fab and press delete table and it pops up. Delete table structure fab, I say, oh, no, not this table. I press cancel and select the one I actually want to delete, log, and again press delete table. Yes, this table I do want to delete, okay. And now notice that after deletion, everything is deactivated in the program window until we select a new table to continue working with. I select a table and everything comes back, all the buttons are active again. This visual all grayed out state is another nice LabVIEW reminder that you just did something serious with data. It's like the UI saying, table deleted, take a breath, choose the next one carefully. These are the additional functions available to the administrator. So this completes our review of the executable program database tool. In the next episodes, we'll look at the compilation process and how to create an installation file, how to sign the executable and installation file with a code signing certificate, how to create and attach a license and disclosure agreement, and other options when creating an installation package. We will also in future episodes go through the source code in detail and look at how each function is created. Thank you for joining LaPlanta Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to learn more from upcoming episodes.